Hello students, welcome back to the channel, and today's session we are going to continue with part B, chapter number 12, electricity, grade 10, subject of physics. In part B of electricity, we will discuss about Ohm's law, resistance and resistivity. In part B, we will discuss about Ohm's law, resistance and resistivity. So what is Ohm's law? Ohm's law here, it is connected with the current flow and the potential difference. As the current flow increases, potential difference also increases. So we say that always remember at constant temperature. The current flowing through a conductor is directly proportional to the potential difference across its ends at constant temperature. The temperature being constant, the current which is flowing through a conductor will be directly proportional to the potential difference across its ends. So mathematically, how you will represent that V is directly proportional to I. If you want to find out V, you can use this magic triangle. Among the three, you can use anything. V equal to I times R, where V is the potential difference, I is the current, and R is the resistance. By using a magic triangle, you can find among three, any one. This is your Ohm's law. Potential difference unit is V, current is ampere, and resistance is Ohm. So verification of Ohm's law. Ohm's law can be verified experimentally. So here when the potential difference is increased, current also increases. So the ratio of V over I remains constant. So VI, potential difference and current graph. As VI, voltage current graph plots voltage on the y-axis and current on the x-axis. Its slope will represent the resistance. Electrical resistance of a component can be find out by finding the slope by using the formula R equal to V over I, which is your Ohm's law. If you have an IV graph where current will be on the y-axis and its resistance will be the reciprocal of the slope I over V. Always remember, a steeper line on the graph means greater resistance. If the line is very steep, then it is having greater resistance. That is, it is harder for electricity to flow. So what is the resistance? It will oppose the flow of electric current. The resistance will oppose the flow of electric current is called resistance. Symbol is R and the unit is ohm, omega. So how you define 1 ohm? A conductor has a resistance of 1 ohm. What is happening here? You have a conductor which has a resistance of 1 ohm. If the potential difference of 1 volt will produce a current of 1 ampere. If a resistance is having 1 ohm, that is, the potential difference will be 1 volt, and that potential difference is going to produce a current of 1 ampere. Now, what are the factors which will affect resistance? Length, cross-sectional area and nature of the material. Length is represented by L, cross-sectional area is A, nature of the material, and the temperature. The important relations here you remember, that is resistance is directly proportional to length. What is happening? If length increases, resistance also increases. If length decreases, resistance also decreases. Then what about the area? That resistance is inversely proportional to the area. Resistance increases, area decreases. Resistance decreases, area will increase. Next comes, with this we have the formula. After resistivity, we will discuss that formula. The resistance offered by a conductor of unit length and unit cross-sectional area is called resistance. What is happening here? The resistance offered by a conductor. How much is the length of the conductor? Unit length. And how much is the area? Unit cross-sectional area. So how much resistance is offered by it is called resistivity. This symbol is represented by rho, and the SI unit is ohm meter or omega meter. As I said, we will discuss the formula later. This is your formula, students, that R equal to rho L over A. R equal to rho L over A. If you are transposing A towards the left hand side, Then A times R equal to rho into L. Rho equal to A times R over L. So rho units, area unit is meter square, resistance unit is omega, length unit is meter. Meter gets cancelled. So rho unit you will get meter omega meter. Here is a one solved numerical. You have a current of 2 amperes which is flowing through a resistor connected to 12 volts. What you need to do? You need to find the resistance. So V equal to 12 volts, I equal to 2 amperes. So formula we have from Ohm's law, R equal to V over I. Just put the values. That is the reason, students, we need to write given R equal to 12 over 2. Answer will be 6 ohms. Second question you can see. A resistor of 5 ohms carries a current of 3 amperes. You have a resistor of 5 ohms which is carrying a current of 3 amperes. You need to find the potential difference. V equal to I into R. So V is 5, V you need to find, I is 5 and R is 3. 5 times 3 is 15 volts. The third numerical is you have a resistance of 20 ohms which has a potential difference of 40 volts. You need to find the current. Again by using Ohm's law, I equal to V over I. The magic triangle you can use. 40 over 20 will be 2 amperes. The answer will be 2 amperes, students. For any further queries, you can use the WhatsApp number or the comment section. The notes, a link has been attached in the description box. You can please check. For any queries, please you can WhatsApp to both the numbers or you can use the comment box and clarify your doubts, students. Thank you very much, students. We'll meet soon with part C.